Let's continue with some simplification with constants, variables, inside and outside. All right, so now we have a coefficient of negative m. That's going to affect nothing for now of simplifying what's in the radicand. All right, we're going to have to worry about that later. We're going to have to multiply whatever we take out by negative m. All right, so we'll put that negative m to the side for now. And now I'm going to break down root 80 m to the ninth into root 80 and root m to the ninth. So now I'm dealing with my constants and my variables separately. All right, so now let's go through our list. Perfect squares that can go into 80. 4, absolutely. Off to the side here, I'm going to do 4 times 20. All right, that works because 4 is a perfect square. But if I look at 20, 20 can also be broken down into 4 and 5. Isn't 4 another perfect square? Which means, let me try to, build here. If I multiply these two, that's 16 and 5. 16 and 5 also multiply together to get 80. 16 is a perfect square factor. 5 is not, which is perfectly fine. But if I break down 80 into root 16 and root 5, now I have 4 root 5, where 5 is done. Root 5 is done because 5 is prime, can't do anything in there. I'm going to remember to bring down my negative m out in front. Now I'm going to work with my m to the ninth. M to the ninth is odd, so I can't do it. There's not going to be a perfect square. But what I can do is I can break m to the ninth into the biggest perfect square factor. The biggest perfect square factor at m to the ninth is going to be m to the eighth. It's always one less. And then we still have one m left over. I could put a little 1 up here, but I don't need to. All right, so now m to the ninth becomes m to the eighth times m, both under the radical. The square root of m to the eighth. All right, I know it's kind of getting long, but picture this. This is the same step of doing root 16 is the same as 4. Root m to the eighth is just going to be m to the fourth. Root m, I just dropped down my root 5. That was not a perfect square. Neither is root m. So I have root m. So now I have all my pieces. Now I just got to put it together. All right, I have this negative m out in front. And remember, there is a 1 up here. All right, negative m to the first times 4 times m to the fourth. Now I'm multiplying them together because they're not under the radical. They're not radicand. So I can multiply all of them together. All right, I have 1m here. I have 4m here. That gives me m to the fifth. All right, I still have a negative. I still have a 4. So that's just going to become negative 4. So my coefficient is going to be negative 4 m to the fifth. That's what I get when I combine these pieces, okay? Now I'm not done. I'm still going to have a radical. What's left under the radical? We have a 5, we have an m. We want to do 5m. Please note that the constant does come before the variable. It's just more proper that way, all right? But when we simplify negative m, root 80 m to the ninth, it breaks all the way down into negative 4m to the fifth, root 5m.